Good evening, everyone. My name is Yogini Kautik. I am third year student of Civil Engineering Department in MIT Academy of Engineering, Anandi, Pune. I am presenting the topic of Introduction of Bridges. Bridges serves as crucial infrastructure in civil engineering, enabling transportation over obstacles like rivers, valleys, and roads. Understanding their classification, components, and design principal forms and the core bridges engineering education. In this video lecture, we study about the types of bridges, their principles, their, their design principles, and components. This presentation will explore bridges types, their structure components, important hydraulic concepts such as afflux and score depth, and the critical IRC load specification guideline. Their design, we will also examine common failure causes observed in Indian bridges to comprehensive understanding. Then next is the classification and types of bridges. Uh, in our video lecture, we explain the four types of bridges. First is beam bridge, simple structure where the deck is supported by beams resting on piers abutments, and ideally these beams for short span. These beams are only for short spans. Then arc bridges, curved structure that transits loads mainly in compression along the arc to the support, suitable for medium spans. This is suitable for medium load or medium spans. Truss bridges, framework of triangular that distribute forces efficiently, used for moderate to long spans. Then last is the suspension and cable stayed. Modern long span solution using cables to support deck suspension, and the flexible cable stayed bridges have direct cable connections. Key components of bridges: deck, piers and abutments, bearing and expansion. Then see what is the deck is. The roadway surface carrying traffic loads across the span. It transmits loads to the supporting elements below. Then piers and abutments. Vertical support transferring loads from the deck to foundation. Abutment also retain the embankment at the ends. The piers and abutment plays the very important role in bridges. They transfer the load to foundation. Bearing and expansion joints. Bearing allow controlled movement and rotation between the deck and support. Expansion joints accommodate thermal expansion and contraction. Concepts of economical span in bridge design. Definition, importance, factors influencing span. Definition: span length that achieves the most cost-effective balance between material, material use, structural efficiency, and foundation expenses. It defines the span length achieves the most cost-effective balance between the material and structural efficiency. The importance: selecting the economical span minimize overall cost while ensuring structural safety and serviceability. The span should be selected economical, and if we select the economical span, then overall cost and ensuring overall cost will be reduced and the structure structure will make safety and serviceability structure. Factors inclusion span, site geology, material availability, type of bridge, construction technique, and maintenance consideration. The various factors that affect on span. The site geology, the site should be best for the span, and the material availability. The material should be choose by doing their various tests, and the construction techniques, their maintenance will affect in on the factors. Then the hydraulic considerations, afflux, HFL, and score depth. Afflux, rise in water level upstream of a bridge due to obstructions of flow critical for fluid management. High fluid level, the maximum water surface elevation during flood important for pier height design. Score depth, the erosion depth around the bridge foundation caused by the flowing of water. These factors affect the score depth. In this slide, it say the height of bridges is designed depending upon the high fluid level. Loads acting on bridges. There are 3 loads acting on bridges: dead loads, live loads, environmental loads. Permanent static loads from the weight of structural element, non-movable fixtures are known as dead loads. In dead load, we take an example of non-moving components or materials or one element that may stable at one position. This is called as dead loads. The live load means we can transform the element one position to another position, is called a live loads. Transit loads from traffic, pedestrian, and movable equipment. Then the third is the environmental loads: wind, earthquake, temperature variation that impose dynamic forces on the structure. IRC load specifications for bridges. Class AA loading represents very heavy traffic loads with trucks and trailer use the important highways. Class A loading, standard loading with medium trucks typically for most highways and rural roads. Pedestrian and cyclist loads, lower loads and foot bridges and cycle paths specified to ensure safety and comfort. Impact and dynamic factors. Additional load multipliers to address vehicle impact effects, vibration, and braking forces. The common causes of bridge failure in India: foundation score, poor maintenance, overloading, design and construction deficiencies. In foundation score, excessive erosion around foundation causes instability and collapse, particularly during floods. In foundation square, we don't know the flood is in what time they coming, and the foundation score will happen. Poor maintenance, lack of timely inspection and repair, leading to structural deterioration over time. If we do not maintenance our structure timely, then the structure will go automatically in deterioration. Then overloading. If we apply load, if we apply load by increasing the capacity of it, then it it will be overloading, and the excessive loading will failure the structure or bridges. Overloading, exceeding design load limits with heavy vehicles or unauthored usage accelerates damage. Then, design and construction deficiencies, inadequate design detailing or substandard material components. Design and construction. If we do not design the bridges properly, then automatically the design and construction deficiencies happens. And we construct the bridges properly. Case studies. Notable bridges failures in India. First is the Morbi Bridge collapse in 2022, attributed to corrosion, undericed section, and lack of maintenance leading to tragic failure. In this Morbi Bridge collapse, they don't take bridge maintenance. They don't carry out the bridge maintenance, so the bridge may fail. The bridge get fail. Then second, Kochi Bridge failure in 2017 due to score and undermining of foundation during flood, highlighting hydraulic risks. This bridge will get fail in. This was fail in undermining foundation during flood. And third, Howrah Bridge repairs. Successful example of maintaining a heritage bridge through monitoring of retro. The third bridge of Howrah Bridge is the best example of successful maintenance of bridge. Key takeaways and next steps in bridge engineering. Holistic design. Integrate structural, hydraulic, and geotechnical aspects for safe economical bridges. We have to take the next steps for safely bridge design. First is holistic design. We design our structure in hydraulic, and we test our soil and their geotechnical properties, the economic of bridges, their safety. Then we design and construct our bridge. Then adherence to codes. Follow IRC standards meticulously to ensure compliance and longevity. Third is culture. Maintenance culture. Implement regular inspection and upkeep to prevent premature failure. Research and innovation. Pursue new materials design methods and monitoring technology for safety and serviceability of our bridge.